Hi everyone, I'm just making this video for my 2020 biology students and Miss Camp's 2020 biology students, just to help address some of the questions that are arising for you as you try to pull together your scientific poster for Unit 4 Area of Study 3. So I just wanted to introduce this by reminding you of the scientific process. So the whole purpose of this activity is to allow you to investigate an idea and apply the scientific content or the biological content that you've learnt this year to an experiment. Now, usually what you would do is choose a research question from a selection that we present you with, and then design your own method and collect data over an extended period in the lab. And you might do that 3 times, 5 times. You might run multiple experiments while you refine your method, and then hope to collect reliable, accurate data and that you can analyze and discuss in a scientific poster. Now, as you know, and this actual wheel here that you see is from VCAR. They give this to us to basically help step you through the scientific process that we're expecting you go through. But as you know, that this year is a little bit different. In that we're not in the laboratory and you're not going to have a chance to collect the data firsthand. But what we have given you is a selection of data to choose from on a range of different topics. And you still are going to be able to meet most of the criteria that we would usually expect you to do, but in a second-hand data off-site kind of way. So we've given you the data, and the data will is on a range of different subjects. One is fermentation. We've given you a set of fermentation data. We've given you 2 sets of photosynthesis data to choose from. So you can choose the effective wavelength or light intensity on the rate of photosynthesis. And we've gone through the Melbourne University excursion on evolution with you, and you've generated a little bit of data yourself, and we've presented you with a whole set of data to analyze with that one. So you've got 3 topics: photosynthesis, cellular respiration, and evolution to have a look at and choose between. What you're going to have to do is actually start from this point down here. Instead of starting with your research question, you start with the data that you're going to analyze, and you try and work out which research question might support that data. Might that data have come from? Then write yourself an aim and a hypothesis to reflect the data that we've given you. So you're kind of going backwards around the wheel and then forwards around the wheel in 2020, which is one of the challenges we're facing. So once you've developed your research question, which most of you have already done, and your aim and hypothesis, then you've defined the problem quite clearly. You then need to write the method, and that's where many of the questions are coming from that I'm getting at the moment. How much detail does the method need? If you haven't had much practice in writing scientific posters, then it does have a slightly different emphasis than a full practical report that you might write on pages and pages. It's more brief, but it still needs to be reliable. It still needs to be a fair test. Still needs to be well controlled and able to be repeated. Okay, so the emphasis is on being more visual, being more succinct, which is why the word count is quite tight, but also ensuring that the way that you communicate is extremely clear and concise and scientific as much as you possibly can. So within your scientific design, you do need to tell me about volumes and concentrations and masses. That's where much of your research will probably go. Okay, so you will, in developing your experimental design, and you would do this even if you were in the laboratory, you try and work out how much yeast I need to achieve this volume of carbon dioxide. Do I do 500 grams? Do I do 1 gram? You know, what kind of volumes and masses am I actually, and what volume of water am I resuspending in, and what's the temperature of that water? They're all really key questions for you to ask yourself and to include in your methodology. So starting from the data that you've chosen, make sure that you've got a clear hypothesis, clear aim. You've given us some background from your own research, And those expectations aren't different to what we would have of you in the laboratory. How you write the experimental design, we're not going to penalise you if it's not exactly right, if it doesn't actually work. If the volumes are slightly out, that's absolutely fine. Just do your very best to actually define those and ensure that you're controlling the variables appropriately, and you've defined exactly the range of independent variables you're testing. Then you'll use the data, you'll present the data in an appropriate way, and once you get back into school, you'll have most of your poster written without the discussion and conclusion written, and then we'll do that under controlled conditions. Make sure that you pay close attention to the rubric. This is on LMS in the U4AOS3 3 folder in the resources, but this is really important. This is how we're going to assess your poster. So this is the single source of truth. This is the most important document you'll see. The sample that we've posted for you is one from previous years, and the context was different. We did actually do the experiment, obviously, and I think that's an enzyme, a biochemical pathways example. So just use that as a guide to how a poster looks and how to organize it. Again, that wasn't 100% that poster, so it's not, there is certainly some areas for improvement in that one, and we think that you can actually write the perfect poster and hit all of these high marks given the time and investment and research that we're hoping that you will do. So use the rubric. Do all of this prior to coming back to school. Make sure that you do tick off each of these boxes. Here it says apparatus list. Now you don't need a list of how many pipettes you're going to use, but you do need to be very clear about how you'll measure the mass. So you do need to include in the method that the volume was measured using measuring cylinder, a 50 milliliter measuring cylinder, that kind of thing, so that you're actually being very, very clear on how to measure that volume, how to measure the mass of the yeast using electronic balance, so that you're making sure that those variables are precisely controlled. So make sure that you understand what fair, reliable and safe means from a scientific perspective, so that you're meeting that criteria and you can get the highest marks in there. And then what you'll see is the recording data section here. We need you to make sure that you present the data in a really visual way. Make the graph an important part of the poster so that it's not small and difficult to read, because the whole idea of a scientific poster is it's very visual, and the images speak for themselves to an extent. So pay attention to that and make sure that you have prepared now, but not written, the sections here in the discussion. Okay, so you need to be able to, once we get back to school and once we go into the GFL or wherever we get to do the final SAC, you need to be prepared to write about your data. You need to be prepared to bring in some good content about your data, describe the limitations, errors and how they can be overcome in the future, and draw valid conclusions from the data that we've given you. Okay, so this part here is not written on your poster just yet. So the submission to the Dropbox by the end of week 1 of term 4 does not have any discussion or conclusion written into it. You will have those sections blank and you'll do those under control conditions with us. But you do need to be thinking about these sections and this part of the rubric as you're writing, because as you're analysing the data, that's a really good time to start noticing things. As you're writing the method, it's a really good time for you to think about how you could improve the method and what possible limitations there are associated with the method that you've chosen. The last page of the rubric is for you to do now. It's like an overview on how you've communicated using the scientific poster style. It's where you get the marks for appropriate formatting, appropriate referencing. We've not prescribed which referencing system you use. So whichever one you're comfortable with is fine. Just make a note of the referencing system. So if it's APA 6 or whatever it might be, just state that, or Harvard. Any of them are fine, but please make sure that you include appropriate references in your poster, and that within the text you have references. So whenever you've used someone else's work, you may have found online someone else has done exactly the same experiment and you want to draw some comparisons. You need to cite that appropriately within the text and then at the end. Your terminology needs to be spot on, and it's a great opportunity for you to practice using the correct terminology and think about the biochemistry that's going on in the background. If you're doing respiration or photosynthesis, make sure that you're using the appropriate evolutionary terms. All of your diagrams need to be supported with some text. They can't just be decorative images, which is what I call a photograph of equipment without an annotation on it. That's just decorative and it's useless. So you need to annotate them. You need to have captions and ledgers. And the word count is tight. 1,000 words is designed for the whole thing. So if you drop off about 200 words of that, the Dropbox document should be around 800 words. There's not many marks allocated to that, but you can't write 2,000 words or 100 words. That's not going to meet the requirements of the rest of the rubric. So that really is a guide for you as to how much detail to include in your poster. As I said, if you have further questions, please reach out. This is an extended investigation. It is quite a lot of work, and it does require you to be a little creative, because all we've given you is the data in the rubric, and we're expecting that you find out how you might be able to achieve that data in a good scientific way, and then you go back and you analyse it. Good luck, and reach out if you have further questions.